Hey folks, welcome back to another video. Today we're looking at question 2191. Sort the jumbled numbers. The way we'll be solving this problem is by creating a 2D array. And the 2D array will basically map the numbers that we see in mapping and like the converted values. And the conversion will be based on we actually take the numbers from nums and then we convert them based on the mapping that's given to us in the mapping array and then store them. And the reason why we're using a 2D array for mapping instead of some sort of like a hash map or a tree map is because since the values can be converted to the same mapped values, so that's the reason why we're using a 2D array instead of any other like paired sort of collection. And once we have that, we'll use the array sort method and create a custom comparator to compare them between compare the numbers between the mapping. And then once we have them sorted, we'll reassign them to the returning array. It's relatively simple if we go at it step by step, so let's get started. The first thing that we need to do is actually create the 2D array. So let's get the size. So this will give us a size of the array, and we need to create like the 2D array, and then let's just call this mapping to new array of size n and of 2. So this will be a 2D array, and what's next? Yeah, so basically we need to iterate through all of the numbers. Int I equals 0, I less than n, increment I. So the first value will basically be mapping of I of 0 would be equal to nums of I. So basically you're saying, okay, this is the value that we're taking from the array, and the number that has to be assigned to it will be whatever we create in the algorithm below. So there's one base condition that we need to handle. So basically if nums of I, if it is equal to 0, you just set it as is. So that would be mapping of I of 1 would be equal to mapping of 0. And the reason why that is because this is the base case and isn't necessarily covered by the algorithm that we'll be creating here, and we'll see that in a second. So we need to iterate through every single character, right? So we need to look at every single character and go to the mapping array and then create the integer value. So let's create an integer called mapped value, which we'll keep working with, and then we'll have like a multiplier, and we'll set that to 1, and it'll soon become obvious why. So we'll say int j is equal to nums of I. This is a number that we're working with, and as long as j is greater than 0, you'll keep dividing it by 10. So what we're actually doing is we are getting the modulus. So this would be, we get the mapping for the last number that we're looking at, modulus 10, yeah, so modulus 10, and then you multiply that by the multiplier, and it'll become obvious in a second. And then the mapped value, you'll just keep adding to this. So what exactly does that look like? So if we go through an example of, let's say 991, right? Example of 991. So what's happening in this algorithm is that you want to start off, you could either start with 9, 9, 9, and 1, or you could go with either you could go from left to right or right to left. And the reason why it's easier to go from right to left is because you can just get that number by doing modulus. But if you had if you want to go from left to right instead, you have to figure out what tens that you require to keep dividing it by every single time to get the number that's the leftmost. So that's the reason why you go from right to left, because it gives us easy access to that. So in the first case, we know that the value is 1, and we map that to 9. Is that correct? Yeah, so we map that value to 9. Mapping of 1 will, yes, exactly. So we'll map that to 9, and then now the way the number is taken care of is 99. You get the modulus, you get 1, and you convert that to 9, and then this is assigned to current. So this is like the mapped value. Mapped value is assigned 1. Map value is assigned 9 actually, because it goes from 1 to 9, and then the actual number is divided by 10. So 991 becomes 99. And in the next case, we modulus this. So the mapped value will become 9 plus whatever this value is mapped to. It'll become 6. However, since this will have like a 10 added to that, because this takes second place, you need a multiplier. So in the first case, if you multiply this by 1, nothing happens to it, but in the second case, you actually need to multiply it by 10, and you need to keep increasing the multiplier by 10 times every single time you do that. So the other thing that you actually need to do is actually multiply it by 10. So in this case, we'll multiply it by 10, right? And then if you just continue the algorithm, this becomes, the map value becomes 96, and then you're multiplying it by 10, so it becomes 960, and then you take the last value. So this map value is divided again by 10, so in this case this is j. So this becomes, when you divide it by 10, it becomes 9, and 9 is mapped to 6, so you add, map value becomes 960 plus 960 plus 6, right? So the value becomes 966, and that's the mapped value that you get in the end. Yeah. And then when you divide this again by 10, this becomes 0. So that's the stopping condition that we have, as long as j is greater than 0. Right? So that's I would recommend going through a few examples to understand this if you haven't really done this before. And in the end, once we have gone through all of it, this is actually 1, where you store the mapped value, and this becomes the first value is actually the mapped value. So this will take care of the mapping. The next step is actually to create the custom arrays sorter. So the way we sort arrays is basically arrays.sort, right? And then you give the name of the array. In this case, this is mapping, or we should actually call this mapped, because we have this array called mapping, so it will conflict. So let's call this mapped. Let me see where I have to replace it. Yeah, that's fine. Yeah, I think that's fine. Okay. So you need to sort the arrays mapped, and then you need to take the two values that you need to compare, A and B. And given A and B, the way you'll be sorting them is you need to return them in the non-decreasing. So basically you need to integer.compare, and you're providing the two integers. But since it's a 2D array, so A and B here represent like one cell, which is mapped of I of 0, mapped of I of 1. So here you'll be comparing a of 1 with b of 1, because the second cell is what is storing the mapped value. And you might be asking, oh, what if they are of the same value? How does this take care of it? So since right here, since they are the same values, it'll be returned in the same order. Therefore, it will still hold the condition where even if they're mapped to the same value, they should appear in the same relative order. So this takes care of that condition as well. In the end, you basically need to iterate through the mapped values again, and we'll be using the nums array that's given to us to actually reassign the values and send it back. So this will also be int I equals 0, I less than n, increment I, nums of I equals to mapped of I of 0, since that's the actual value that we care about, the original value. And then in the end, you return nums. Okay, let's try compiling this. Okay, let's see. So this is the problem. Integer.compare. These are the values that we are comparing. What's the error again? Oh, so for two, like a 2D array given a and b, int arrays.sort. It's not applicable. Mismatched. Argument mismatch. Let me see that again. That should actually be fine. Oh, right. Oh. Okay, at least it's working. And here, like, the numbers are off. I'm sure I made a silly mistake. Okay, let's look at it again. Okay, int n equals nums of length mapped, so new int of n of 2, that's fine. For int I equals 0, I less than n, I plus plus, mapped of I of 0 is equal to nums of I. Yeah, that's fine. Yes, that's fine. And then if nums of I is equal to 0, we just map the value to be mapping of 0, that's fine. If not, the mapped value is equal to 0, multiplier is equal to 1. For int j is equal to nums of I, j greater than 0, j divided by 10. Mapped value would be equal to, let's just put this in brackets just to be safe, mapped of, you take j, you get the modulus of that, and then you get the mapping. Yeah, and then you multiply that by the multiplier. Yes, I think that's a mistake I made. Let's try compiling this again. Okay, yeah, that's a mistake I made. When there are too many variables involved, I would recommend being super careful with it. I think because this is a little convoluted, so take care to make sure you're using the right variables. Alright, so the first few test cases are okay. Let's try compiling and submitting it. Okay, everything else is okay as well. Awesome. So if you have any questions, please let me know in the comments below. Ooh, actually, let's talk about the time and space complexity. The time complexity of the entire solution is of n log n. Anytime any sort of sorting is involved, the algorithm is n log n, unless there is another part of the problem that takes more time than sorting. and the space complexities of n, since we are using additional space to store data that we care about. Awesome. So if you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.